Imagine you're living in London in 1952. It's 3 weeks until Christmas, and you wake up ready for work. You look outside your window and you can't quite see the other side of the street through the heavy smog. You step outside and begin to have trouble breathing. The visibility is so poor that you can barely see your own feet. You have trouble focusing at work, and you're a little dizzy. And when you get home that night, you can barely sleep due to the horrible racking coughing that you just can't stop. Though you don't know it, your lungs are filling with pus, but you can't make it to the hospital because ambulances can't drive through the smog. You never make it to Christmas. This was the unfortunate reality for over 6,000 people living in London in December of 1952. An unforeseen air pollution catastrophe, the worst the country has ever seen, caused by burning sulfur-rich coal. Atmospheric catastrophes such as these punctuated the 20th century. We punched a hole in our ozone layer, and we accelerated anthropogenic climate change at an unprecedented rate. We are still struggling with these problems to this day. The chemistry that caused the 1952 smog wouldn't be solved until 64 years later. If we'd understood more about our atmosphere, we could have prevented these problems. My research aims to fill these gaps in our knowledge. I'd like you to take a deep breath with me. Most of the time, we don't worry about what we're breathing. If there's oxygen, we're happy. But in reality, we just breathed in a complex chemical cocktail of tens of thousands of different molecules. This is the puzzle that atmospheric scientists such as myself are trying to piece together. Now let me introduce you to one of the puzzle pieces, formaldehyde. The first organic molecule to ever be discovered in our atmosphere, and one of the most important. I've discovered that in the short time after formaldehyde absorbs light, it becomes incredibly reactive with oxygen. It effectively burns, with sunlight acting as the match that ignites it. This mechanism solves a problem with unexplained chemical products that has puzzled atmospheric scientists for over half a century. It produces these free radicals. Now, these free radicals are a bit different to the ones we're used to hearing about in our bodies. They're sometimes called the detergent of the sky because they scrub our atmosphere clean of a lot of the chemicals that we put into it. Now, this burning mechanism that produces these free radicals is theoretically possible for thousands of molecules in our atmosphere. Our sky could be on fire and we never even realized it. 64 years later is too late for the people that died in 1952. Discoveries like these will allow us to get ahead of the next atmospheric disaster and prevent it.